We've been discussing the generalized second price auction, which is widely used to sell search advertising. What the major firms do is some version of this auction. That generalized second price auction is actually, in fact, a generalization of second price auctions to selling multiple items. Remember, a second price auction that we've talked about before was really designed for selling a single item, and the generalization that Google, for example, needed was one in which they're selling many items, that is, many slots. The problem is that in this generalization, the dominance of truth-telling is lost. In the second price auction, truthful bidding is a dominant strategy, and that's not true in the generalized second price auction. However, there is a generalization of the second price auction to multiple items that in fact has truthful bidding as a dominant strategy, and it results in an assignment that maximizes total valuation. So what we want to do is talk about that alternative generalization, a generalization that was actually around long before the generalized second price auction. And to do this, it's easiest to start with, in fact, actually a second price auction for a single item and just reinterpret it. So imagine running the auction this way. The seller asks bidders to announce values, as in a second price auction. And the seller says that the item is going to be sold to the bidder with the highest announced value. That price the bidder pays, the winner, is not their bid. But we're not going to say it's the second highest bid, although it will turn out to be that. Instead, we're going to say that the price the bidder pays is the harm that this bidder causes to all of the other bidders by taking the item that they get, computed using their announced values. So the price you're being charged is the harm you do to everybody else by taking the item away. Seems like a sensible concept. We're going to show that this actually is just a way to reinterpret the second price auction. And let's do that in the context of the example that we've been looking at for selling search ads. So remember, here's that example from before. We had 4 slots with the number of clicks per slot ranging from 10 to slot 1 all the way down to 1 for slot 4. We had 4 advertisers, A, B, C, and D, and they have values for clicks ranging from 8 down to 1. And here we have the advertisers ranked from high value per click down to low value per click. And we simply calculated their values for slots. So for example, advertiser C's value for slot 1 is 80. It's $8 per click times 10 clicks on slot 1. Advertiser A's value for slot 1 is 50. A's $5 per click times the 10 clicks on slot 1. That's the example we looked at before. Now that has multiple items. It has 4 slots. Let's suppose instead that the world was simpler. There's only 1 slot. So now we're in the setting of actually the second price auction. Let's suppose that we run a second price auction with this reinterpretation. And suppose for the moment that these bidders here, A, B, C, and D, actually bid truthfully. That is, they bid their values for the slots. Well, then we're going to assign the slot, the one we have, to bidder C because bidder C bids the highest value of 80. What are we going to charge bidder C? We want to charge bidder C the harm that C does to A, B, and D by taking the slot. What's that harm? Well, that's the best alternative use those other bidders could have put to that slot, which was to give it to bidder D, who has a value of 70 for it. So the harm that C does by taking the slot is D's bid of 70. That's what we'll charge C. Now, of course, that's exactly charging C the second highest bid. We're just reinterpreting it. And in that setting, we know that, in fact, it's a dominant strategy for everybody to bid truthfully because you want to win if you can, and if you can do it with a bid that's less than or equal to your value. So let's think through the second price auction here just a little bit more. There's 2 key aspects to this. The first is that in the second price auction, all your bid does is affect whether you win or lose. It does not affect the price you pay if you win, because that price is the harm you do to everybody else. What do you want to do in terms of bidding? Well, you want to win as long as you can do it with a bid that's less than or equal to your value. You never want to bid more than your value because then you might win and pay a price above your value. And the same sort of thing on the low side, and we've done this before. But the key here is that what you pay is determined by others' bids, not by your own bid. Your own bid only determines whether you win or not. The generalization of this idea to many items is called the Vickery-Clark-Groves procedure, VCG for short, and we're going to go through how it works. We're going to do it in the case of advertisers and slots, but it would actually work for any setting with multiple buyers and multiple items. So let's suppose we've got B advertisers. B is the number of advertisers, and we have S slots. And we'll make B equal to S. Other cases are possible, but it's easy to turn them all into a B equals S case. Every advertiser has some value for slots. That's the thing we created earlier in our example. So let's suppose that the value of slot I, advertiser J, is some number Vij. That's J's value for I. Here's the way the VCG procedure works. We ask the advertisers to announce values Vij. They don't have to announce the truth. They can say anything they want. Given those announced values, we're going to create the matching of advertisers to slots that maximizes total valuation. And then we're going to charge each advertiser a price for the slot they're given. And the price we're going to charge is the VCG price. That price is going to be the harm the advertiser does to everyone else by taking their slot, their assigned slot. So what are those prices? Well, suppose we assign slot I to advertiser J. What's the harm that that does to the others? Well, it's going to be the best the others could have done had they had that slot, and the difference between that and what they actually get when they don't have that slot. We need a little bit of notation to do this. So let's let Vs sub B minus J be the maximum total valuation of all slots over all the advertisers except J. B minus J. That is, we want to look at what the others could do if they had all the slots. Vs minus I, B minus J, is the maximum total valuation of all the advertisers except I, and, except J, and all the slots except I. So this is what the advertisers except J could do if they had everything except the slot that we've given to J, slot I. The VCG price is the difference between these two values. So it reflects how much harm advertiser J is doing to all of the other advertisers, that group B minus J, by taking slot I away. And that's exactly the idea in the second price auction. Here it's just a little more complicated because we have multiple items. Let's take this back to our example and see how it works. So again, here are the advertisers' slots and their values per click. Suppose that everybody announces values truthfully. The question is, what's the matching we're going to have of advertisers to slots? Here it's easy. Right? We're going to give the slot that has the most clicks to the advertiser who in fact has the highest value per click. So C is going to get slot 1, and C is going to bid 80 for it, of course. And we're just going to march down through advertisers with values per click and clicks per slot. So we're going to pick up the diagonal in this matrix with C getting 1, D getting 2, A getting 3, and B getting 4. That matching maximizes the total value given the announced prices people have for their slots. And here it's actually fairly simple because of the way we're generating values for slots. Now, let's take those announced values. Remember, we're assuming for the moment they're truthful. We're going to show later that they will be. And ask, what are the prices you're going to charge? So the VCG price to, let's say, advertiser C should be the harm that C causes to D, A, and B by taking away slot 1. Well, what is that harm? Okay. Let's first suppose that C wasn't there, but D, B, and A have all of the slots available. What are they going to do with them? Well, we're going to create the maximum possible valuation for matching of the slots to the advertisers. We've only got 3 advertisers left and 4 slots, so one's going to get unused. And of course, that's going to be the 4th least valuable slot that's never assigned. We'll assign slot 1 to advertiser D because D has the highest value for it, and so on down the list. So we'll get this green line of assignments here. That is the value that they can get from all of the slots if C is not around is 70 plus 40 plus 3. But they don't have all the slots because we gave slot 1 to advertiser C. In fact, all they have left is slots 2, 3, and 4. What can D, A, and B get from 2, 3, and 4? Well, they can get what they had in our matching, which is 56 plus 15 plus 1. That's the total valuation we can give the remaining advertisers using the remaining slots, the one left after we gave slot 1 and gave it to C. The difference between those two values, here it's 41, is the harm that advertiser C causes to everybody else by taking slot 1. And that's the VCG price that C is going to have to pay. So with these announced values, C pays a price of 41 for slot 1. And we can compute this for the others too. But rather than do that, we want to move on and begin to think about what are people going to bid. Will they in fact bid truthfully, as they do in the second price auction for a single good? And that'll be our next topic.